Alrighty. In this video, we are going to look at more on overestimating and underestimating. So looking at number 19 here, we want to jot down a couple of notes that we will know in terms of what we have for our graphs right here. So here, notice how we had left Riemann sum and our function was increasing. A left Riemann sum is going to underestimate, and a right Riemann sum is going to overestimate. So if you are increasing and you have a left Riemann sum, it's going to be under. If you have a right Riemann sum, it's going to be over. Well, guess what? If you have a decreasing function and if I have a left Riemann sum right here, notice how here, if I do my leftmost points, I'm overestimating right here. Overestimating. So that means that if I'm decreasing, if I have a decreasing function, I have an overestimate if I have a left Riemann sum. Well, for right Riemann sum, I'm going to have an underestimate right here. So I'm not filling out the small parts right here. This is going to be an underestimate. Now, in addition to that, we also have the trapezoid rule and the midpoint rule. These are going to be dealing with your concavity. So here, if you have a function that concaves up and you're using the trap rule, you're going to have an overestimate, which means that the midpoint is going to be an underestimate. And then if I have something that's going to concave down, that's going to be an underestimate. And then your midpoint is going to be an overestimate. So notice how here, if I have C, this is a concave down function. And if I go from 1 to 2, I know this isn't going to be the best. But if I go from 1 to 2, or maybe let's do 1 to 3. If I go from 1 to 3, notice how here I have this small part that I'm not taking account of. So that's why here, if I have a concave down function, then trap rule is going to give us an underestimate. Likewise, if I have a concave up function, and I do from, let's say, 1 to 3, notice how I'm taking into account of this small part right here that's over my graph. Can't really see it that well, but you get the idea. So when in doubt, just sketch some function and see if it's an overestimate or an underestimate. So looking at number 20 here, we want to see that a trapezoid sum gives us an overestimate, which means that we have a function that concaves up. So we have an overestimate or overapproximates that's concave up, meaning that it can't be B and it can't be C. And then we have a right Riemann sum that underapproximates. So we have an underestimate, underapproximation. So an underestimate would be a function that is decreasing right here. So looking at A, notice how A is decreasing and D is increasing. So our answer choice is going to be A. Now, if you don't want to memorize this, once again, you could just look at the answer choices and actually draw out the rectangles and see what happens. So if I have a right Riemann sum right here for number 20, notice how here I am underestimating because I haven't taken into account this part, or this part right here. So that would be an underestimate. Whereas part D here, if I were to do a right Riemann sum, notice how I'm taking into account of the whole area under the curve, but then a little bit more. All right, so the main goal of this video is basically number 19 right here. Either memorize this or just think logically in terms of if it is an overestimate or an underestimate. In the next video, we'll look at the definition of a Riemann sum and what that is and why area is really important.